an image along a vector. How can I translate an image along a vector? A vector, here's your symbol for, this would be called vector y. A vector determines direction and movement, direction and distance. A vector determines direction and distance when translating an image. Don't put a question mark. It's not a question. I clicked undo, but it undid my N. So a bunch of not big words but medium words that means this. If you have triangle ABC, and you're going to translate it along vector y, it means to take each vertex in this triangle and move it the same direction as the vector and move it the same distance as the vector. So it's almost like if you could copy this vector and then paste it on point C, well then point C prime would probably be about here. Agreed? And then if you copied it and pasted it on point A, I'm guessing it would be about here. And if you did the same thing to point B, B prime, and then you could connect those vertices. Remember yesterday we said that if you connected the vertices after the reflection, they create a perpendicular with the line of reflection, and the vertices are the same distance away from the line of reflection. Agreed? Well, today, tell me what's going to happen here. If I connect C to C prime, and I connect A to A prime, and then B to B prime. What can you tell me about the relationships of those three dashed lines to the vector? They're all the same length, aren't they? So they're the same length. And what else? They're all parallel. Very good. They're parallel and congruent. So your translation of the shape is going to be parallel and congruent to the vector. So like yesterday, the first part of your assignment, you're going to be given an image and you're going to be given the vector. The vector is going to be on the textbook, printed. You're just going to have to redraw the image after the translation. Okay? Second part of the assignment is going to be just like yesterday. You're going to be either given coordinates or you're going to be given the image on the coordinate plane, and you're going to be given the vector in a different format. Alright? So right now I want you to, we're going to create this little table relating to the vector and the movement of the shape given the vector. So looking at this vector y from the previous problem, what can you generalize about the movement of that shape? Where did it go? What's that?
Onto the points.
Right, but if you had to describe the movement of that triangle to someone in relation to a piece of paper or a coordinate plane, yeah. Just describe how the shape moved, Derek. Huh? It went up and to the right, didn't it? It went up and to the right. Okay? So look, it went up and to the right, or it went right and then up. Agreed? So its horizontal movement was to the right, and its vertical movement was up. So when you're given the vector like this, you're given it basically as an xy. And what this means, a vector 2, 8, means to move the shape right 2 places. Because coordinates are in the form of xy, agreed? And if we increase the x value by 2, we're going to the right. So if 2, 8 means right 2, where else are we going? Going up 8, good. It's that simple. If our vector is -1, 3, we're going left 3 and... No, we're going left 1. Sorry about that. Left 1 and up 3, right? Okay, my bad. Left 1 and up 3. And what if we go -5, -9? Left 5. Down 9. What if it's 0? 0, -6. Nothing happens to the x value of the image. So this is unchanged. And then down 6. Everybody get the idea? If you're given the vector and it looks like this, what the movement of the shape is going to be.
What does a vector that looks like just a straight down?
For your x to be unchanged and your y to go down 6, yeah, it would look like this. Yeah, straight down. You know, left 5, down 9. So that's left and down, so that's more like this, right? Left 1, up 3, so we're going from here, we're going left and up, more like that. Right 2, up 8, so we'll go right and up, so it's more steep. It's like the opposite of slope. Slope is rise over run. Agreed? These vectors are like run over rise, or run then rise. Okay, you're running horizontally, left or right, and then you're rising, or what's the opposite? Sinking. Okay. So here's what the rest, or some other types of questions will look like. We're going to graph each figure. And its image along the given vector. So we're going to get triangle EFG with point E at -7, -1. F is at -4, -4. G is at -3, -1. And now watch, here's where they put the vector. You'll see a semicolon and then 2, 5. So based on that information right there, which way is that shape moving?
Upright.
It's going right 2 and up 5, isn't it? So what we're going to do next is we're going to list the coordinates of our E prime, F prime, and G prime. So our E prime, if we're going to the right 2, we add 2 to -7, -5. And if we're going up 5, we got -1 plus 5. Good. And then you do the same thing for your F prime. So we're at -2 and 1. And then for G prime, -1, 4. And then you could graph the pre-image and the image. Any problems with any of that? Any questions?